Assalamu alaikum. Good afternoon. I'm Kaushik Ahmed along with my group members Rafiullah Shurid, Mohammad Imon, Mohammad Atayar Rabbi, and Rafin Kobir. We're here to discuss about the assignment and final presentation of basic mechanical engineering. To discuss about the problem, first problem we can see that is to define the refrigerant, tons of refrigeration, and the conversion of tons of refrigeration into kilowatt. Refrigeration is the process of removing heat from an enclosed space or a substance for the purpose of reducing the temperature. Refrigerators and air conditioners both use a refrigeration process to remove heat. We all know that heat always transfers from hot temperature to cold ones. That makes it doesn't happen on its own, rather than rely on electrical and mechanical energy conversion. As the heat is removed and the space becomes cooler, it's a very important necessary process in today's world, as it helps us to preserve food, medicines, and so on. And it helps us to have a ideal temperature for comfort of human. Next comes refrigerant, and the refrigerant is the medium through which heat exchange occurs. It's often a liquid that absorbs heat from the room or the area that is desired to be cooled, becomes hot itself, and then condenses the condenser. We use freon, which is a CFC gas, as a coolant or refrigerant. It's very heat sensitive, which makes it ideal for heat transfer and use as a refrigerant or coolant. Tons of refrigeration. Tons of refrigeration is a unit of heat extraction capacity of refrigeration or cooling equipment. Generally, tons of refrigeration. 1 ton of refrigeration is the heat transfer amount to freeze or melt down 1 ton of ice from 0 degree centigrade to 0 degree centigrade at a time period of 24 hours. It's the capacity of, or the power of the cooling device. Next comes the conversion of tons of refrigeration into kilowatt. As previously discussed, tons of refrigeration is from 0 degree centigrade to 0 degree centigrade of 1 ton of ice at a time period of 24 hours. So there are no temperature changes, but the heat energy changes. So the heat changes equation is the latent heat of freezing into its mass, which is 1000 kg or a ton, equals to 3.334 into 10 to the power 6 joule. And then to make it to power or kilowatt, we have to divide it by time and 1000 to make it a kilowatt. The time is 24 hours, which is equivalent to 86,400 seconds. After calculation, we get that it's approximately 3.67 watt, okay, 67 kilowatt. But it's the theoretical or theoretical conversion. In practical, in actual practice, we, due to system loss, we usually get approximately 3.5 kilowatt per ton soft refrigeration or TR. Thank you for staying with me. My group members will carry on solving the problems. Assalamu alaikum.
My name is Rafin Kabir and I will talk about human factors, the four factors that affect human comfort. So the first one is temperature. So the ideal temperature is 21 degrees Celsius. When the temperature of the surroundings is more than 21 degrees Celsius, what happens is heat enters from outside to the human body and the temperature of the body increases. This makes us feel hot and this makes us also feel uncomfortable. At the same time, when the temperature outside the body is lower than 21 degrees Celsius, what happens? Heat from inside the body transfers from the body to the surroundings. Then the human body feels cold and shivering may occur, and this also makes us feel uncomfortable. The second factor is humidity, or we can say relative humidity. So first of all, I'd like to explain that the relative humidity is the amount of moisture present in the air divided by the total capacity of the air to hold the moisture. So ideally we want the relative humidity to stay 50%. When the relative humidity is more than 50%, what happens is, since already there are so many water molecules in the air, sweat from our body cannot escape the skin, and so that we feel uncomfortable and we feel hotter than the weather actually is. And when the relative humidity is lower than 50%, what happens is, since sweat can escape our skin more easily now, since the air doesn't have that many water molecules, so we feel so water vapor from our skin easily evaporates, so we feel dry skin and we also feel uncomfortable. That's why. And the third point and the third factor, which is another important one, is the purity of the air. When the air is impure, it's hard to breathe and we can experience many symptoms such as an irritated throat. So the air must also be pure, which the air conditioner does by using a filter. And the last factor, which is also another important one, is the motion of the air. When the motion of the air is too much, then sweat is easily removed from our skin and this makes us feel cold since we are losing heat faster. And when the motion of the air is low, we feel hotter because the sweat cannot escape our skin very easily. So all of these four factors are important and an air conditioner aims to control all of this. For example, a summer AC cools us down. Also, an air conditioner can change the humidity by increasing or decreasing the humidity, and the motion of the air can also be controlled by using a fan.
Assalamu alaikum, sir, and good morning, everyone. Thanks for giving me the chance for the presentation. I'm MD Imon here. So far, my fellow team members have discussed a very important topic. Now I'll discuss about the major component of an air conditioner. So there are four major components of an air conditioner. First one is compressor, the second one is condenser, the third one is expansion valve, and the final one is evaporator. So at first talk about the compressor. A compressor also known as heat of our air conditioner. It is a vital and often expensive component of our air cooling cycle. This device keeps our home cooling and comfortable during the warm weather season by converting power into energy and circulating the refrigerant necessary for the heat exchange process. Simply put, without a working air conditioner compressor, we don't have cool air. The air conditioner compressor is situated within the outdoor unit. The compressor's job consists of circulating the refrigerant needed during the heat exchange process through the coils. Think of this as an energy source for air conditioning system. The electricity that runs through the home AC compressor powers the air conditioner to absorb the heat from our home to formulate cool air and push it back into our house. The cooling process of the air conditioning compressor starts with the motor. The motor powers the compressor with a cylinder and piston. So it is the work of compressor. Now let's have a look at the condenser. A condenser is the outdoor portion of an air conditioner or heat pump that either releases or collects heat depending on the time of the year. The condenser coil receives that hot pressurized gaseous refrigerant from the compressor. Then the condenser coil is designed to release the heat the refrigerant is carrying outside. This cools the refrigerant down and turns it back into a liquid ready to absorb more heat from our home. Now let's talk about expansion valve. When the refrigerant leaves the condenser coil, even though it releases most of its heat outside, it's still too hot to re-enter the evaporator coil, so the expansion valve works by decreasing the pressure of the refrigerant and cooling it back down even more. The expansion valve sends the cold refrigerant back into the evaporator coil, where it picks up more heat from the air inside our home, and then process repeats itself. Now finally, talk about the evaporator coil. The evaporator coil is place for absorbing heat. Like when the fan blows hot air from our home over the cold evaporator coils, the cool liquid refrigerant inside absorbs the heat from the air completely, then continues on through the evaporator works the opposite of the condenser. Here, a refrigerant liquid is converted to gas, absorbing heat from the air in the compartment. This causes the refrigerant to absorb heat from the warm air and reach its low boiling point repeatedly. The refrigerant when vaporizes, absorbing the maximum amount of heat. So here is the end of my part. My portion has finished and my next fellow member will discuss the further presentation. So thank you everyone. Thank you very much.
Good afternoon, ladies and gentlemen. My name is Rafiullah Churit. I'm a student at AIB. Now I am going to my presentation. Today I will talking about the 6 major equipment will gonna be used in air conditioner, like damper, filter, preheater, humidifier, reheater, and cooler, and also cooler. Before going to the discussion, we have to know that there are 2 types of using air conditioner. One types of summer air conditioning system, and another types of like winter air conditioner system. Both cases equipment are same, but some of them equipment are not same. Now we come to the point. The presentation slide is come to the point. Damper. The damper used to fix the motion of the air into laminar flow, and also damper is the significant equipment of air conditioning. Now come to the point, the second equipment like filter. The fundamental work of a filter is to clean the dirt of the air and make sure clean air into the air. Now come to the point preheater. Preheater is the main equipment to heat it up the air. It comes to the damper and the filter. Humidifier like it water to spray in the air. In like it moisture in the air, and it will make comfortable of the from the human body. Like outside humidity was 35%, this humidity is not comfortable for the human body at all. Reheater used to finally heated up the air and desired temp. We use consider coil in reheater, but in the preheater we use electric coil. Okay, assalamu alaikum, sir.
Air conditioning system has 7 different categories. They can be classified according to the purpose, according to the region of the air, according arrangement of the equipment. They are below: winter air conditioning system, summer air conditioning system, year round air conditioning system, unitary air conditioning system, center air conditioning system, comfort air conditioning system, industrial air conditioning system, winter air conditioning system. The air is heated in winter air conditioning system, which usually accompanied by humidifier. The outside of the air is mixed with the recycled air passing through a damper, which is obtained from the conditioned space after the removing dirt, dust and other pollution from the combined air. The air is now passed a preheater coil to prevent the water from freezing and keep humidifier evaporator under control. Summer air conditioning system. Summer air conditioning system. It is the most common type of the air conditioning system, which is cooled, dehumidified. Is in general outside air is mixed, which is recycled air is passed through the damper, which is obtained from the circular basis after a filter removing from dust and other pollution is combined air. Now the air force is flow